That's better. Can you see my screen?
Yep, perfect.
Okay, perfect. Okay, so hi everybody. Thank you for inviting us. My name is Cristina Palmero, and I'm going to present our proposal for Amazon Mechanical Turk, Understanding Dyadic Interactions from Egocentric Multiviews. So I'm very happy to be presenting today this dataset, as it's the very first time that we publicly talk about it. So this dataset was designed to analyze and understand human behavior in face-to-face dyadic interactions. So essentially, we wanted to study how humans behave, influence each other, react, and adapt as a function of the task and their respective individual characteristics. So as we can see on the image on the right, we have two people who are interacting with each other, performing a series of tasks. These participants are wearing a chest-mounted camera from which we can see the first-person view and also the second-person view, but we also have a time-synchronized third-person view or global view of the scene so that we can jointly reason about what's happening on the scene at a given point in time. These participants are performing non-scripted tasks that imply progression over time, which means that we have continuous recordings that start when the participants start the task and finish when the participants complete the tasks. And these tasks have a series of steps. In a face-to-face dyadic interaction, there are many things going on, but for this proposal, we're focusing specifically on human-object-human interaction and dyadic intentions, as I will show in a minute. Okay, so more concretely, we want to annotate two non-scripted structured tasks that we can see on the videos on the right. So on the first video, we have Lego building, in which two people have to build a Lego together following a set of instructions. This task fosters cooperation, collaboration, and joint attention, and elicits leader-follower behaviors. And then on the video on the bottom, we have a card game, which is called Ghost List, in which participants had to compete against each other to be the first in selecting the correct figurine with respect to shape and color, depending on the figurine that they see in the card. So this, of course, fosters competitive behavior, and it allows to analyze cognitive processing speed and reflexes. The dataset consists of 147 participants, which were distributed in almost 190 dyadic sessions. We have variability in terms of gender, age, and also country of origin and speaking language. Actually, this dataset is a part of a bigger dataset, which includes audiovisual recordings from 6 third-person view cameras. We have the heart rate as well, profiling data from the participants before and after each session, the relationship among interactants, whether they know each other or not, and the transcripts. This dataset was designed together with experts in personality and dyadic communication. And to the best of our knowledge, there is no similar dataset with respect to the number of views, participants, and dyadic context. So moving on to the proposed annotations, our proposal contains fine-grained annotations in the form of the start and time events. What's an event? So an event follows the template form over here, which is basically a sentence explaining what's happening in a given period of time. And it follows the form of a sentence, like with subject, verb, and complements. For instance, we have the subject and the hand performing the action. We also have the objective action, which is basically the physical action, like grab, attach, turn. We have the direct object, which is the object that receives the action, like the Lego brick or the figurine. The indirect object, which can be the other participant or a location. For instance, in this case, put the Lego brick on the other side of the table. The indirect object will be the other side of the table. And finally, we have the intention. Showing a brick, this term show would be the intention. It's the purpose of the objective action, and it usually has a dyadic meaning. So workers will be requested to annotate all the events that they see on the video. Here we can see a draft of the tool that the workers will see. And the good thing is that these single events could be later combined and ordered in time to create more complex sets of events to be able to analyze interaction in a proper way. We acknowledge that annotating start and times is challenging and also is the intention. So we will add we will include some mechanisms to handle data ambiguity and data quality. Let's see some examples of intentions and actions. For instance, here we have the intention offer. And one intention can be described with different actions. For instance, this intention here can be described with the action hold, push, and leave. And the other way around. For instance, for a single action, which is grab, this action can imply different intentions. Like here we have offer, receive, and steal. The proposed annotation scheme and the dataset itself offers a vast amount of possibilities and applications. So we are planning to organize a challenge for next CVPR 2021 or ICCV, depending on the timing, focusing on recognition and anticipation of actions and intent. But for the future, we could also consider applications such as skills recognition and leader-follower recognition, among others. So with respect to the timing, we already have the collected data set. We are planning to release it to the public by mid-September. And also the Amazon Mechanical Turk tasks will be published by mid-September, so that by mid-November, we can have all the required annotations to start the challenge. And to conclude, our goal here is to collect a complete set of annotations in the most rigorous way to have a useful and challenging data set to be able to advance research in the field. So taking into account the characteristics of the events that we want to annotate, the number of assignments per hit required in order to compute the inter-rater agreement in a robust way, and also the mean number of events per task and minute, we foresee that we will need around $15,000 to make this happen. We're trying our best to reach this quantity, so that's why we are here. And any help on this will be much appreciated. That's it. Thank you very much, and waiting for your questions.
Thank you, Christina. I know a couple of other members of the team are in the chat. I think they have the option to unmute for any questions if they want. So one question, is a single Turker going to annotate all the events in the video? If so, this can be a challenging task. What if the Turker misses some events? So that's from Antonino.
Okay, so we're planning to divide the videos in 1 minute, 30-second video clips with 30 seconds overlap because the context is very important to annotate some things like the intention. What if it misses some events? Well, that's a good question. We will add a gold standard, annotating more or less 5% of the data set, so that we make sure that all the annotators annotate all the required events. And also, prior to the start of the annotation task, they will be required to follow a tutorial and a template validation to obtain a qualification to start our tasks. So to try to maximize the number of events, of correct events, of course.
Thank you. Another question. What interesting applications do you think this dataset will enable that existing Dyadic datasets don't?
I will pass this question to Sergio. Sergio, do you want to answer?
Yeah, sure. Can you hear me?
Yeah.
Yeah. Okay. Mainly, we have done this application with our colleagues, the psychologists, and we envision that in order intelligent agents to interact with the environment and know better each other, they should know how we should interact with the others and how it depends based on the personality at the different profiles. So the amount of data this data set contains is very comprehensive. And then we think that being able to recognize this very fine-grained action and behavior of people interacting will allow this intelligent system with egocentric computing to better interact with humans in real environments for many applications in health and supporting people.
Great, thank you very much.